Hello, welcome to this video on degree and radian measure. What I'm going to do is talk about what radians actually are. It's really just a unit of measurement, just like degrees. So we'll walk through kind of a conversion of it. We'll talk about what a radian actually is. We're going to look at reference angles, something called a coterminal angle, and then we'll do some conversions between degrees and radians. So a couple degree ones, a couple radian problems, and that is about it. So I'm going to start off first of all talking about what radians are, and I'm going to do it based off of something that you know, which is circumference. And circumference was equal to 2 pi r, r being the radius, and then we have this pi. Pi is a ratio of something's circumference to its diameter. So what I'm going to do is say, okay, suppose the radius of something was 1. Okay, so if I had a radius of 1 and I drew a ginormous circle here, that's a really bad circle. If I drew that circle and I want to know the circumference of it, I would use this formula, and my circumference would be equal to 2 pi times 1, which is just 2 pi. So that's loosely where this idea of a radian comes in. A radian itself is a unit of measure expressed usually in pi. So if I say what is pi radians, well, we know a full circle, what I just went through, is 2 pi. So a half circle is 1 pi. So we say that a half circle, or in other words, you're used to seeing this as 180 degrees, that is pi. And that's where this whole pi over 180 conversion comes in. So if I give you an angle measure, you can simply multiply or divide by 180 over pi, and that would give you the converted angle measure. So let me just give you an example of that. Let's say I had 210 degrees, and I wanted to take this angle measure in degrees and convert it into radians. What I would do is multiply it by pi over 180. So what you would really have is 210 times pi, so that's 210 pi over 180. And then all you do is simplify this expression just by figuring out basically what's the fraction in lowest terms, and you keep the pi there. So you don't go to the calculator and like throw 3.14 in. You express it in terms of pi. So my radian measure, 210 over 180, simplifies to 7 over 6. The pi comes down. So if I said 210 degrees, the same angle measure could be called 7 pi over 6 radians. And then I would just flip-flop that logic then. I would just flip-flop that logic if I were to be giving you a radian measure. If I said I had 3 pi over 4 radians, what I would do, instead of multiplying by pi over 180, I would multiply by 180 over pi. So if your radian measure angle has the pi with it, this pi is going to cancel with that pi. And really what I'm going to end up with is 3 times 180, which is 540, and I would divide by 4, and that's going to end up being 135 degrees. So that's just quick conversion back and forth. So we're going to play around with that a little bit. The other thing that we're going to talk about is something that's called a coterminal angle and a reference angle. So I'm going to draw or just sketch out where 135 degrees would be. This is roughly 135 degrees. If I just label my quadrants, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So if I labeled this angle as 135 degrees, positive 135, because we're going counterclockwise, a negative angle measure, you would go clockwise. So first, coterminal angle, and that's coterminal is basically going to say, what's another angle measure that's going to produce this same side right here? And this side is called the terminal side, and this side is called the initial side. So what we're looking for is, what is another angle measure that's going to give me basically the same terminal side? AKA, if I were to go around this way, what would my angle measure be? So I can take a look. This would be 180 degrees, plus I would just have to take a look at how much more I needed on top of my 135 to get to 180. So from 135, I would need 45 degrees more to get to 180. And again, if I went 180 degrees this way, I would just take my 180 and add my 45. And what that means is that this angle going around clockwise would be negative 225 degrees. The other way that I could really get that is just, if you know a full circle is 360, just take 360 minus 135. You're going to get 225. So if you just tack on the negative sign, that says, hey, we're going clockwise. So one of my coterminal angles would be negative 225. So typically what you'll see in the problems is I'll say, well, what is one positive and one negative coterminal angle? Well, we know our negative one is negative 225. So I'm thinking, what's another angle that's going to produce the same terminal side? And all that you're going to have to do is think about that angle and just tack on another 360 degrees. If I were to go around 360 and then add on 135 degrees, sounds kind of weird, but I would have a 495 degree angle. That is a coterminal angle. What that means is 495 degrees is going to produce the same terminal side. So if I had one positive and one negative coterminal angle, my positive would be 495, my negative would be negative 225. And then lastly, the angle that's produced between the terminal side and your x-axis, so this little guy right there, that is referred to as the reference angle. Okay, that's just a weird R. Reference angle. And that would be, in this case, 45 degrees. So we're going to just go through a couple problems identifying all that stuff that I just whipped through in a really crummy explanation. First thing, I have an angle that is 150 degrees. So what I'm going to do is sketch out where 150 is, and it's a positive value, so we're going to go counterclockwise. 150 would be right about here. So I know that I can draw my terminal side. First thing I'm going to just get out of the way is actually the reference angle, which is saying how much more would I need to get to 180. So I could just take 180 minus 150, and that's going to give me a reference angle of 30 degrees. So that knocks out this little one. As far as the quadrant goes, this is in quadrant 2. So now going through what I had just mentioned, we're going to give one positive and one negative coterminal. So I'll start with the positive one, which just says, okay, if I wanted to produce the same terminal side, I'm going to go around my circle 360 degrees, and then I'm going to add another 150. So all that you have to do is take 360, which is my full circle, and add 150 degrees. So my positive is going to be 510 degrees. And then your negative one, you just have to go around clockwise. If I were to go 180 degrees this way, that's going to make my half circle. I would need 30 more degrees to get there. So 180 plus that 30 is negative 210 degrees. Basically it. Lastly, the radian conversion. I'm going to take my 150 degrees, and what I'm going to do is multiply this by pi over 180 degrees. So as far as units go, you have a degrees on top and a degrees on bottom. Those cancel out. The pi is measured in radians. So I really end up with 150 pi over 180, which if you want to simplify and be lazy, you can go to the calculator, if you have a TI graphing calculator, and type in 150 divided by 180 and hit enter, and you're going to get an ugly decimal. But if you hit the button on the left side of your calculator that says math, the first option will convert it into a fraction. And simplest form is 5 over 6. All that you have to do is tack on the pi. So you're not putting the pi in the calculator, you're just putting in the 150 divided by 180. And again, that's going to give me 5 pi over 6 radians. So let's go through another example. In the next one, I'm giving a negative angle measure first. So negative 315. So negative meaning I'm going to start going clockwise. This is 90, there's my 180. Here's 270. 360 would be too much. So 315 is going to be somewhere up here. I'm going to sketch my terminal side. If I want to know what my reference angle is, forget negatives for a second. Just realize a full circle is 360. If I take 360 minus 315, I'm going to get a reference angle of 45 degrees. Okay, so right away I have that. The fact that I drew this clockwise makes it negative. So the easy part of this is identifying what my positive coterminal angle is. Since we're going from the x-axis just up here, my positive coterminal angle is just 45 degrees. A negative one means I need to take a full negative 360 around my circle. So if you take negative 360 and you add on negative 315, you're going to get back up there again, and my negative coterminal angle will be negative 675 degrees. It's a really ugly diagram. And then lastly, this is quadrant 1. So what I'm going to do is that radian conversion. I'm going to take negative 315. I'm going to multiply this by pi over 180. Once again, you can just express it as a fraction of negative 315 over 180. And if I want to simplify this in my calculator, take negative 315 divided by 180. It's going to give you a decimal. And you can hit the math button, go to fraction. It's just a lazy way of having your calculator do the work for you, of getting 7 over 4. So you're tacking on the pi, and your radian measure would be negative 7 pi over 4 radians. Alright, so I'm going to do the same thing here, except these ones don't have the coterminal angles, so we're going to just skip that part for now. We'll label and give the reference angle, except this time we're going to start with radians. So in this first one, and this is where I want to start getting good at fractions right away, we know we are going 5/3 of a pi. So this is a full pi. So anything more than that, when you have an improper fraction like this, I would recommend writing it as a mixed number. So what this means is 3 goes into 5 one time with a remainder of 2. So I'm going 1 2/3 pi. So what I want you to think about, as if I were to go full pi, that takes care of my 1. Now, just look at the bottom half of this circle. I want to go 2/3 of the way. So imagine me breaking this bottom up into 3 pieces. Piece number 1, piece number 2, and piece number 3. We are going 2/3 of the way. And that is something we'll kind of work at over time, is how to get this angle right here, because this is going to give me my terminal side. What you might want to do right away, just to get some number sense, get your conversion out of the way in degrees if you are more comfortable with degrees. So I'm going to show you again how we can do that. We can take 5 pi over 3. Since I have a pi on top, my conversion will have the pi on the denominator, and that's going to cancel out. So what you're really going to do in your calculator is just take 5 times 180 divided by 3. And I'm going to end up with an angle measure of 300 degrees. And if we think about that, it makes sense where I sketched that. Because this would be 90, this would be 180, this is 270, and then a little bit more gives me my 300. So I'm going to identify that this is in quadrant 4. And then we just want the reference angle. So if this was 300 degrees, that means I only need 60 more. And once again, if you didn't know that, you can just realize full circle is 360. I'm going to subtract my angle measure of 300, and I'm going to get my reference angle of 60 degrees. And then lastly, a negative one. So negative 7 pi over 6. Again, if you want to convert this right away, go ahead. Negative 7 pi over 6, if I multiply this by 180 over pi, your pi's are going to cancel. And then in your calculator, you can just take negative 7 times the 180 and divide it by 6, and you're going to get negative 210 degrees. So this is negative 90, there's negative 180. 210 means I need to go like 30 more past my 180, and it's going to give me a side right about here. So again, if we knew this was 180 degrees, my reference angle is 30. And something I want to mention, this is a good example to mention this on, even though we drew the angle going in the negative clockwise direction, my reference angle is still a positive value. Your reference angle is always a positive value. So even though we sketched the angle as negative 210 degrees, your reference angle, which again is the angle formed by the terminal side and the x-axis, that angle is always a positive value. And then terminal side here is in quadrant 2. Once again, if I made a sketch of this, just to show you, if I wrote this as a mixed number, 6 goes into 7 one time with a remainder of 1. So I really have negative 1 1/6. Just to give you that number sense again, negative 1 means negative 1 pi. So you're going a whole pi, which is a half circle, and then I'm going 1/6 of the way. So imagine dicing this like top part into 6 pieces. So 1, 2, 3, 4, 5, 6, and only going 1/6 of the way. Okay, and then we'll kind of talk more about radian conversions in the future and which angle measures are going to be really important ones. But that is it as far as this goes. So just quick recap on this stuff. Went through the degree and radian conversions, talked about how we have a terminal side. From your terminal side to the x-axis builds a reference angle. If we wanted a positive coterminal angle of something, and it was a positive angle measure, we just added a positive 360. If you wanted a negative coterminal angle, we just went from the other direction then and figured out what would produce that same terminal side. And then a couple examples of these conversions, and that was it.